Anyway, so this one is real-time soil diagnostics has arrived. And again, Dan Owen here is presenting. Thank you.
Perfect. So we'll whiz through this. So this is a presentation on kind of where we're at today. How do we make soil sampling more trendy, more efficient, so that guys actually start to use it? So, challenges, we talked about biologicals, we talked about nutrition, but if we don't know what our soil needs, we can't act on it. So we need to get those results back quickly. So, evolution of analytics, we're going to run through this quick. We need to evolve and think differently, okay? We need to start with a soil test, and this can be a challenge. Some guys think they do a great job when they take a soil test for NPK and S. You'd be better saving your money. When you take a soil test, it needs to be NPKS, micros, base sats, pH, organic matter. Now we can look at what's going on in that soil and make a decision. So when we start looking at conferences around the world, this was in St. Louis, approximately 15 million samples are tested each year in North America. Only 20% of arable land is ever sampled. That's interesting, isn't it? So how are these guys building fertility programs if they've not taken a soil test? Most soil test data is incomplete. Like I say, no organic matter, no micronutrients, no texture data. We focus on the macros because we understand macros, don't we? We know nitrogen makes yield. We know if we've got a little bit more cash left in the bank that phosphorus will help make yield if we can afford it. Potassium, we don't need it out in Western Canada, and we need a lot of sulfur. That's kind of where we sit, isn't it? Okay. So, when we start to look at it, the frequency of soil testing for nitrogen in Canada is poor. 58% of people only test for nitrogen every third year. What's scary about this is it doesn't matter what soil test you do, it always has nitrogen on. So it tells me that 58 people are testing their soils every third year. So how can I make a nutrition program? Okay, I'm just guessing. Fucking thing. Bear with me. There we go. So, what are the reasons why people aren't soil testing? Okay, let's zoom these boxes. There you go. So, reasons why people aren't soil testing. It's too expensive to do it thoroughly enough to be useful. I can't do my whole farm, so I'm not going to do it. Well, why don't you take a couple of samples and at least see where you're at? Don't think soil tests are that useful. That just means you don't understand them. Don't trust soil test results. Fair comment. Every lab's different. My advisor does not advocate using annual soil testing. That's a poor advisor. Okay? No services available to do this. Well, there's multiple labs, and if you've got a shovel, you can take a soil test. That's a bad excuse. Nitrogen levels do not change from year to year. Oh, yes, they do. And I can show you 10 years of soil tests that show you they do, depending on what crop you grew, when you grew it, what rainfall you had, what the season was like, etc. But that's a real stock response because at the end of the day, it shows the mentality. Nitrogen levels don't change year on year. That's all I'm interested in. I don't care about the other nutrients. And I only apply the amount of fertilizer I can afford. Great. But what if you didn't need that much nitrogen and we could put more phosphate on to get a better response? Do you think that could be a benefit to your farm? So what we need to do after we've done our tissue test is we need to start, our soil test is we need to tissue test. Because we need to monitor what we've done in the crop. So when we start to look at this, at the minute, most guys are doing one tissue test. We normally do it before herbicide, just to see where we're at. Okay? I don't think this is the best use of your money because all it's going to tell you is you did a good job or a bad job of your fertility program. Really? So look at it. So this is a tissue test on the 16th of June. This was a low fertility site. I didn't put potassium on. I didn't put magnesium on. I didn't put any micros on. Guess what? I kind of expected that, didn't I? And then when I go to the high fertility site, I put magnesium, I put potassium on, I put some boron on, I put manganese on, etc., etc. And guess what? It works. The boron, I know you're looking at that yellow bar saying, well, hang on, you're telling me it works, but you still got a yellow bar for boron. Why do you think that is? Because that site was severely deficient. I could not put enough boron down without hurting the crop. So all it tells me now is I better start a foliar program. Okay? But truly, one tissue test, that's all it's doing. Check mark. You did a great job, guys. I think we're going to start thinking differently, though. I think what we've got to start looking at is we've got to start sampling a couple of times in the season. We need to target those chief stress timings. So vegetative timing, when that crop starts to run, needs a lot of nutrients. Flowering, big increase in things like zinc, calcium, boron requirements. And then at maturation, because I want to make sure I've got nutrients to put into the grain I'm producing. Okay? Whether you like it or not, if we have a good nutrition program, you will grow better grain. You will increase the zinc content of your grain, for argument's sake. Why do you think Bill Gates is spending millions on the Harvest Zinc Foundation to fortify seeds with zinc? And if you don't care about that, you can also increase the germination and vigor of your seed that you're going to put back in the ground by preloading. We need more timely information because the challenge with tissue testing, depending on where you are, it's getting the result back. Take a sample, get a result back, 5 days, sprayer's gone through the field. Plus, tissue tests are a snapshot on the day. Tells you what's going on. The other thing I think we need to do is we need to sample the old and the new growth. Because currently, we sample the new growth all the time. And there's a big challenge with that. See, the challenge with that is in the old growth, all the highly mobile nutrients are, and they can be moved from that bottom growth. I can cannibalize myself to support yield. In that new growth, that's basically telling me what's happening with my immobile nutrients. So every time I take that new growth, when do you think I'm going to find out I've got NPK magnesium deficiency? When it's too late. And I'll give you an example. So, 29th of July, done for effect. I know the plant's shutting down. I know it's running out of steam. So we look at this. I'm looking at this one. I'm thinking, okay, this is good. Nitrogen's low. I'd expect that. Everything else is pretty good apart from zinc and copper. I'm not too worried. So we're going to make a nitrogen plan. We'll probably top dress. Let's change the date to the 29th of June just for fun. So I'm going to put some nitrogen. Let's get some urea through the leaf. I'm going to put a zinc with that. I'm going to put a bit of copper with that. And I'm going to be golden, aren't I? Everything's good. So this is traditional tissue testing. So we do that. These are the old leaves on that same plant. Do you see a problem there? Okay. I see a problem because what I've done is I've completely ignored phosphorus, which drives energy in the plant. So guess what's going to shut my crop down, even if I put nitrogen, copper, and zinc on? All right? So we're missing the point sometimes. It's sometimes a macronutrient that's actually shutting our crop down. And then when I look a little harder, what I can start to see is I'm drying down in the 29th of July, and my boron reserves are starting to pull back a little bit in my new growth. Because I know it's not mobile, so I can't take it out of the old growth. I've got loads in the old leaves, but I'm starting to pull back in that new growth. Okay? That's why we need to think differently, because then a tissue test now becomes analytic. I can react before I see deficiencies of my macros. So basically, they're just a snapshot on the day. Logistics are going to inhibit the time of reaction because, again, best case scenario, 3 days to get a tissue test turned around. So why bother? Truly and honestly, that's what most guys are like. It's like, why bother? As an agronomist, I was kind of like, why bother? So how can I get useful, timely information to act on? Because this is important. I need to check in the morning and move in the afternoon, ideally. So what we want to do is work towards in-field diagnostics. So at the minute, we've got a manganese tester and a phosphorus tester. Walk in the field, clip it to the leaf, zap the leaf, and in 10 minutes, I know what phosphorus is in the crop. I know what manganese. Manganese, so what? I don't care. We don't really struggle with manganese necessarily, but phosphorus, pretty cool. But what about all the other nutrients? So now we need to move to things like near-infrared. And this is an old technology that's been around for years, but we haven't had the computing power to use it. So, real-time testing for manganese, real-time testing for phosphorus. That's the unit. It came out of a lab, and it looks like it did. It's not robust. That ain't going to roll around in your truck very well, is it? And it costs 10 grand. All right? But it's a great piece of equipment. Because what it does, it looks in the middle of photosystem 2, and we need phosphorus for photosystem 2 to progress, and if it's not there, photosynthesis slows down. And I can check that with this scanner. That's pretty cool. The one thing we found with the phosphorus scanner, though, is a lot of the time we get these purple responses. And we thought, this is junk. This is just giving bad reads. And then we talked to the guys out of Copenhagen where the unit was made, and they said, yeah, that could mean you've got manganese deficiency. Because manganese happens earlier in the photosystem chain than phosphorus, so the plant's not even getting to read the phosphorus, or the machine isn't. So basically what you do, you take a leaf, you put it in the dark for 15, 25 minutes, you put it on top of the machine, put it into the light, zap it for 2 seconds, off it goes to Copenhagen, and then basically you get a result back on your phone that looks like this. They made it dead easy. It's a traffic light system. Green's good, yellow's marginal, red's bad. And all it's doing is it's looking on that curve at very different peaks to say, okay, that peak isn't in the right place, photosystem 2 is not running properly, phosphate is low. It's pretty cool. Because it needs to be simple. We need to be quick, we need to be simple and make a decision. So now we move on. So now we're starting to hear a bit in the industry about real-time testing for soil. NPK, organic matter, pH, which is cool. We're identifying the macros because the macros are everything. How many of you guys have heard about Soil Reader? Awesome piece of equipment. Drag it through the field, continually scans the soil, tells you what your NPK, pH, organic matter, and texture are. I think it's a great tool. Really great tool. Just question how it's going to go into some of the clay soils down in southern Saskatchewan, but I'm sure it's a very sharp disc. Then we move on. We saw this. This one actually Case New Holland have money in. Same thing, though. It does NPK, magnesium, soil organic carbon, and texture. So we're missing something, aren't we? Because I'm sure there's more nutrients than those guys. How do I make a decision? And you could argue, well, so what? I can just send a tissue test, soil test to the lab. Okay? But it's real time, this is. So now I can go in the spring and look at my soils. And if I've got that yellow patch, I can say, well, is it a soil thing or is it a plant thing? What's going on? So they're great. But my question to you is, have these products been calibrated? Because what these products develop or generate is a spectra, mass spec. So what are we comparing it to get a result? That makes sense? Because somebody's got to have said at some point in time, those peaks and trough equal X amount of nutrition. So calibration's key for these tools. I don't think there's an off-the-shelf, out-the-box solution. Now what we want, though, is we want a real-time system for testing our soil for all nutrients and base saturations. This is where we get to the product that we're handling or we're working with, and this has been a labor of love. It's taken us 2 years to get to where we are today. So this is a near-infrared scanner. It's called the NutriScan. Fits in your hand, looks pretty cool, looks pretty rugged. That's been rolling around in my truck all summer, and it's a bit dinged up, but it still works. Okay. The beauty with this is a 10-minute procedure. I dig the dirt out of the soil to the depth I want to go. I scan it 5 times and I get a result on my phone. I like that. Okay? And the thing is, I scan it 5 times to get 1 result. Because what it's doing, I take 5 samples, and if I've got 1 outlier, it won't give me a result. It's making sure that those 5 samples are very, very similar. Okay? To get consistency of result. This is what it will scan for. PHCC, organic carbon, inorganic carbon, sand, silt, clay, NPKS, calcium, magnesium, all the micros and base saturations. Do you think that could be a useful tool? And I get it. In soil, it's so what? I can still send it to the lab in the fall. But what we're trying to do with this machine, we're launching it in soils, but 12 months down the line, this thing will do tissue tests. That's where it gets sexy. Okay? You imagine being able to walk into a field, scan the top leaf, get a result, scan the bottom leaf, get a result, scan the soil, get a result, and have 3 points of data to make a decision off in 20 minutes. That's pretty cool. Okay? So, challenge is, I believe, data's nothing without calibration. Because if we're not comparing it to a base, how can I be confident in the result? Okay? So, when we got into this, we thought it was simple. We thought we were going to get this unit, take it out of the box, go zap, 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 and we're golden. Okay? What happened was, the company we were working with said, no. We need 2,100 samples from Western Canada that you're going to scan with this unit, then you're going to dry, then you're going to send them to Holland, and we're going to run them through our lab. And we're going to build you a calibration database for Western Canada that we will add to the 17,000 samples that we have from around the world. That's pretty cool, isn't it? Challenge was, it made us put the brakes on pretty quick because we were going to sell this thing. We were excited. But now, it's like, oh, we've got 2 years' worth of work. We've got to go across Western Canada. We've got to dig. Well, where are we going to get all this soil from? It's a big job. Because basically, we collect the sample, they put it through the gold standard lab. We'll talk about that in a minute, and it goes into the database. That database then runs the prediction module. So what it says is, out of these 2,100 samples from Canada, what do they look like around the rest of the world? And what we've found is a lot of the spectra from Western Canada compare very, very closely to the Ukraine. Because if you think about it, Ukrainian soils, Canadian soils are very young soils. Okay? So we start to see a benefit. This is the map. That's where we had to take our 2,100 samples from. We got sent this map. That's where we needed to take them from. And I'm like, why? Can't I just take 2,100 samples by the back of the office, scan them? Because I'm looking for highs and lows, aren't I? That's really all I'm doing. And they're like, well, no, not actually. And we argued for this for 6 months because I couldn't get it. I'm a little slow. And what they said in the end was, no, but what you need is you need to have the scan, but you need the geo-reference. I'm like, why? They said, because then we can start looking at soil classification charts, we can start looking at geographics, we can start looking at topography, and we can put it all into our database. And now I'm thinking, holy, this is pretty cool. Okay? Been a lot of work. So where we're at the minute, we've got 1,800 samples collected. 400 of those samples were rejected. There wasn't enough dirt. It's like, sorry guys, you went to all that work, can't do it. All right. 750 samples have been analyzed up until about August last year. So our database that we have on our demo machines is running on 750 samples. And some of the data you'll see is between that evolution from the first 300 to the 750. And what they do when they analyze those samples, it's really cool. So they run it through their wet lab, like everybody else would. Then they run it through an XRF machine, which is another spectra looking for different nutrients. Then they run it through the infrared at their office. They do a water extraction, but they also do a resin extraction to show extractable nutrients in the soil. And all those 93 parameters are then put into the database. So not only do I have the spectra from the near infrared, now I have all the parameters from that. And this is why I say data is nothing without calibration. Now I know what I'm comparing it to. Okay? And I'm not knocking any other NIR product, but ask, what did you do to calibrate it? Because what am I comparing it to? Oops. So, the gold standard lab, I talked about the 17,000 samples in the database, I talked about the 93 soil parameters. Nutrient availability is measured with the resins. You guys may have heard of those type products, a bit like the Western Ag Labs guys are using. Okay? It's more robust. So the gold standard lab, it's not a commercial lab. It's purely for calibration. Okay, so these guys take it very, very seriously, hence why they didn't put our samples through that were too small. So what we're putting into the database, so what we're putting in there is that raw spectra off the NIR. Okay, they're easy to get. Then we get the output for after they manipulate them, because when they get to the lab, what they do is they manipulate that spectra to a dry sample, because we're scanning a wet sample, and we need to be comparing apples to apples. Then we get the prediction. Okay? Then we get the reference data, which is all that geo-referenced data. I think, and then we get that metadata in there as well. So this is cool, the layers that go through. And as I say, when I take a sample with that commercial tool, it will look through this database to compare. So this is where we are. This is what we've got left to do. So we said we've got about 1,400 samples. We've still got this chunk of stuff to do, and we're working on that. We were out through the winter. I think through the winter we captured about another 400 samples. We've got another 300 to do in the fall. Okay. But the challenge is we've got to make sure this thing's consistent, okay? I presented this at Farm Forum, and I know I got some comments on that's not consistency. Okay? But we're working on it. Bear in mind, I'm presenting data here with 300 to 600 calibration samples in the database. It's only going to get better the more samples and spectra that we put in. The challenge is, though, when I sat looking at this and first got involved, I'm like, I can't get this to work. Because if this doesn't look like a lab report, with the right numbers the same as the lab report, it's never going to work. I got stuck in a box. And at ATP, we never get stuck in a box. We think outside the box. But for 6 months, we sat there banging our heads trying to get boron to be 1 part per million as a critical value. But why? Because when you think about labs, if you use AgVise, they use DTPA. If you use A&L, they use HCl. The numbers are different. We work to different critical levels. And yeah, it's a pain in the ass to put another one into the market, but as long as we can explain it and have the reasoning behind it, and the calibration to show that compares to, it's got to be a benefit. So, a little bit of noise on the green line. The green line is the NutriScan. Bear in mind, that's with 300 samples. Okay? People didn't like that line because it's scattered. I want to run that line again when I've got 2,100 samples in the database and see what it looks like. I think that will tighten up. And I haven't fudged the axes on the graph to make it look better or worse. Okay? I'll let Excel choose the graph. Then when we look at the red line, that's lab number 2. That's not too bad, but there's a few outliers. Lab number 3's not too lab number 1's not too bad. A little less outliers. Lab number 3, there's still some outliers. They're not as bad, but they've had years of practice. They've got consistency. They've got protocols. They've got their calibration in theory. Okay? Then when we start looking, what we did is we took one soil sample and scanned it 20 times. Okay? So this is showing the consistency between scans. And again, really, I know there's some noise, but again, I guarantee if you take one sample and test it 20 times at a wet lab, you'll see noise. Okay? And again, this is all with 300 samples in the calibration database. So it's not a tight database. This is potassium. So this is a little better. I don't know what happened with the zinc there. I think the guy must have done the back of the shovel or something. A little bit of zinc in the galvanizing. But truly and honestly, the green line, again, a little bit of noise. But they told us the micros were the hardest ones to dial in. But we're getting there because we've worked through the calibrations. This is copper. You know, and I look at the trend lines that are put in there, and I mean, basically I just put a linear line through the points. It's not too bad. We look at boron. And boron was a challenge. I mean, basically when we started getting the boron back, we were getting like 7 parts per million on a 1 part per million soil test. And I'm like, this can't work. And that was the epiphany moment of, well, hang on a minute. The first time we ran this test, when we were doing the calibrations, the calibration database was 0. So we didn't know what to compare it to. So basically what we have, we scan it, we send it in for reprocessing, it goes through a conversion thing, which turns it into that dry sample. It makes a prediction based on spectra and near neighbors. So it can be used in the Ukraine, it can be using fields right next door. So it's making a prediction based on that. And then it issues a recommendation and returns it to the user. At the minute, it's going to just tell you how many pounds of NPKs and yada, yada, yada you need. We thought, we'll be selfish, we'll make it just recommend our products. But that's stupid. Like, come on, guys, if we want to get this industry moving and grow big yields, I don't care whose products really, but let's get fertility right. Okay, we're nearly there. Going to be on time this time. So, sampling procedures, dead easy. If you've got a phone, you're going to be golden. Put the app on your phone, calibrate it once a day. You have to scan the white side of the disk, flip it over, scan the yellow side, that sets the thing up for the day. Okay? Then what we do, it gives you tick marks, it says, yep, you're calibrated, you can start. We have a little cup that we put the soil in. So what we do, we take the scanner, we scan, beep, move it, scan, beep, 5 times. If everything's right and all those scans are very, very similar, it says perfect. And we get ticks in those boxes that you can see on that right-hand side. Then what happens when we get all the ticks in the numbers, up into the cloud, over to Copenhagen, and basically what it comes back is something like that on your phone. Traffic lights again, high, low, medium, yada, yada, yada. Okay? So on the phone, it's kind of a cool toy. To me, traffic lights are like, meh, so what? Telling me whether I'm good, bad, or indifferent. On the back end of this, you can go into a web portal and download all the data in a CSV file. So I can get my parts per million, I can get my percent-based stats, etc. So that's going to be more interesting, because then I can put it into some form of a data management system and start to analyze it. So this is what it looks like when it comes off of the computer. You can see an analysis result. We were just finalizing that on when I took this screenshot. So that will have the number. Okay? So what we've got is a traffic light system just to get you going. Macros in parts per million, total N and Bray. We've got the micros on there, which is cool for near infrared, because again, I don't think anyone in the industry is doing micros with near infrared. Base sats, organic matter, CEC, pH, everything you'd probably see on a standard soil test. This is a really useful piece of equipment, and it's going to be able to do this on a tissue test in 12 months' time. That's why I'm excited about these pieces of equipment. So, where's the future? Complete testing for tissue testing. Need to understand the crop's requirements. Target accordingly to yield. If we don't know what that crop needs, how the hell can we build a fertility program? And if we can monitor it through the season, we can make sure it's good. We need to maximize genetic potential. Nutrient management plans should always start with a complete soil test and be followed with a tissue test, ideally looking at new and old growth, so we understand what's happening with those mobile nutrients. Stay green approach. That just means keep the plant fed. Don't let it cannibalize itself. Okay? It's important. That's the best way we're going to maximize our genetic potential. Go and ask any of the world record holders, because that's what they do. They spoon feed their crops. And analytics, basically, the reason I believe that we need to go more real time is we can identify the deficiencies before we see them. Okay? Think about magnesium deficiency. You guys don't see it very often, but geez, we see magnesium deficiency symptoms. It's 21 days that crop's been wanting something. We need to be able to look at green crops and understand what do you need today to stop that deficiency happening. And on that, I'm going to finish on time. Thank you.
Very good. Thank you, and I know I've been putting the pressure on, but I like to stay things on time because, we have many speakers this morning. I'll allow one question before we move on. So, does anybody have a question here in the audience? I'm sure we have one at least. You all understood that, eh? Okay. I guess you did a wonderful job. Thank you very much, Dan, and on behalf of Manitoba Ag Days, here's a little token of appreciation. And thank you for your presentation. It was great.